Okay, I'm solving questions from the college algebra book. I'm starting with chapter 6 and section 1. So I'm starting with the first example of the book, with of the chapter evaluating a composite function. So I'm gonna try and solve a question from that portion evaluating a composite function. Okay, I already write out the example. This is the first example. It said f of x is equals to 2x squared minus 3, and g of x is equals to 4x. The first question, the A part, it said f circles g of 1, and B said g circles f of 1, and C said f circles f of negative 2. So those are the three questions I'm going to solve. Okay, the first one, A, said f circles g of 1. So what that means is f into g of x. That is f into g of x. And from this question here, g of x is equals to 4x. But this one means f into g of 1. So we're going to replace the g of x with 1 because from the question it says x is equals to 1. So it's going to be g of 1 instead of g of x. So g of 1 means we're going to put 1 for x in the function of g. The function of g is equals to 4x. So g of 1 is going to be equals to 4 into 1. It means we replace g of 1, we replace x with 1. We're going to put 1 here so that 1 is going to come here. We're replacing x with 1. So g of 1 is going to be equals to 4 because 4 times 1, this means 4 times 1, which is equals to 4. So we get our g of 1. So g of 1 is what we're going to put inside f. This is f of x. So instead of f of x, it's going to be f of g of 1, which we just find. G of 1 is equals to 4. So it means now it's going to be f of 4. This 4 is the same as g of 1, which we just find here. G of 1 is equals to 4. So we're going to replace g of 1 with 4. So it's going to be f of 4. So f of 4 is going to be equals to, we're going to put 4 inside the function of f. The function of f is 2x squared minus 3. So that's going to be 2 into 4 squared minus 3. So f of 4 is going to be equals to 4 square means like 4 times 4, 16. So it's going to be 2 times 16 minus 3. 2 times 16 is 32. It's going to be 32 minus 3, which is equals to 29. So it means f circles g of 1 is equals to 29. F circles g of 1. Okay, the big part is g circles f of 1. So instead of f circles g, now we get g circles f of 1. So g circles f of 1 is the same thing here. It's the same as f circles, sorry, same as g circles f of x. So it's going to be like this, g circles f of x. So it means we're going to find the value of f of x and put it inside the function of g. So f of x is the same as here f of 1 because x is going to be equals to 1 here. That is g circles f of 1. So it's going to be g into f of 1. So we're going to find f of 1 first and put it inside g. So to find f of 1, we're given the function of f, which is 2x squared minus 3. So it's going to be f of 1 is going to be equals to 2 into 1 square minus 3. F of 1 is equals to 1 square is same as 1 times 1, which is equals to 1. So it's going to be 2 here minus 3. 1 times 1 is 1. 1 times 2 is going to be 2. 2 minus 3 is negative 1. 2 minus 3 is negative 1. So f of 1 or f of x here would be substituted with this thing is equals to minus 1. So now we're going to go, it's going to be g circles negative 1, which is the same as f of x from this question. So it's going to be equals to, the function of g is 4x. So it's going to be equals to 4 into negative 1. So g of negative 1 is equals to negative 4. That is 4 times negative 1. So the answer to the D part, g circles f of 1 is equals to negative 4. Okay, the third one is C. C we find in f circles f of negative 2. So it's going to be the same pattern here. F circles f of negative 2 is the same as f is the same as f circles f of x. And f of x here is going to be f of negative 2 because x is negative 2. So we're going to replace this x by negative 2. So it's going to be f circles f of negative 2. So we're going to find, the first thing we're going to do is to find f of negative 2 first. So that's going to be f of negative 2 is equals to, you always come back to the function of f of x is equals to 2x. X is negative 2. Negative 2 square minus 3. So f of negative 2 is equals to negative 2 square is same as negative 2 times negative 2, which is positive 4. So it's going to be 2 times 4 minus 3. So f of negative 2 is equal to 2 times 4, which is 8. 8 minus 3. So 8 minus 3 is going to be equal to 5. So the answer to this question is f circles negative 2 is 5 here. That is f circles negative 2 is equals to 5. That is this thing here, not everything. It's just this thing here. F circles negative 2 is equals to 5. So for us to find f circles f of negative 2, we're going to put negative 2 inside f. It's going to be, the answer we get from this thing, when we put negative 2, that is 5. So we're going to put 5 inside f to get this answer. So it's going to be 5 here. This 5 is the same as f of negative 2 is equals to 5. So we're going to replace f of negative 2 with 5, which is going to be equals to, we always go to the function of f. If we're given g, we go to the function of g. If we're given f here, we go to the function of f. So f is 2x squared minus 3. So it's going to be 2 into 5, replacing x with 5, squared minus 3. So f of 5 is equals to 5 times 5 is 25. It's going to be 2 times 25 minus 3. 2 times 25 is 50. It's going to be 50 minus 3, which is 47. So the answer to the C part is 47. Okay, we get our next question. It's example 2. So this one we're finding the function of the, we find the composite function of this thing f circles g and g circles f. Instead of putting the numbers in, now we're just finding the function, and we find the domain of a function. So the first one is f circles g. F circles g is the same as f into this, is the same as f into g of x. That is f circles g. It means we're going to put g of x inside f. Now we're not giving any numbers. We're just going to put this function inside the other function to create a new one. So f into g of x is going to be equals to, we put g of x inside f of x. That's what we're going to do. This is g of x. We're going to put it inside f of x. So f, this thing is equals to, it's going to be equals to, this is x squared. So anywhere we see x here, we're going to replace it by 2x plus 3. So this x squared is going to be 2x plus 3 all square. Like anywhere we see x, we replace it by this. That's what it means here. Anywhere we see x in the function of this, replace it by g of x. This thing is g of x. We're going to put it inside f. So it's going to be 2x plus 3 all square plus 3. We replace this x by g of x, which is 2x plus 3 minus 1. And we solve it. So if we solve this thing, it's going to be this multiplied by itself. So if we multiply this thing by itself, it's going to be 4x squared plus 6x plus 6x. That is, this times itself is this thing here. This times this is going to be this thing here. And this times this is going to be like this. 2x plus 3. So it's going to be this times this is equals to this. This times this is equal to 6x. And this times this is equal to 6x plus 3 times 3, 9. We come here plus 3 times 2 is 6x. 3 times 3 is 9 plus 9 minus 1. So this thing is going to be 4x squared, 6x plus 6x plus 6x, that is 18x. 9 plus 9 is 18 plus 18 minus 1. This thing is 17. So it's going to be 4x squared plus 18x plus 17. This is the function of f circles g. Now we're not giving any numbers to put in there. We're just finding the function. So this is going to be our answer for f circles g. So to see if the domain of f circles g, if you look at the domain of this one, is all real numbers. Like any number you put in here is going to give you an answer. Any number you put in here is going to give you an answer. So the domain is all real numbers. Any number you put in g of x is going to give you an answer. So the domain is all real numbers. So if the domain of the two is all real numbers, therefore the domain of f circles g is going to be all real numbers. See, it's a polynomial. If you put any number in there, it's going to give you an answer. So the domain is all real numbers. Okay, we go to the second one. The b part, instead of finding f of g, we're finding g of f. So g of f is the same as g into f of x. That's what we're finding, g into f of x. And this is g. G is 2x plus 3. So it means anywhere we see 2x, anywhere we see x on 2x plus 3, we're going to substitute it by f of x, which is x squared plus 3x minus 1. So this thing is going to be equals to 2 into, we're replacing x with f of x. This is f of x. F of x is x squared plus 3x minus 1 plus 3. So g of f of x is going to be equal to 2 times, we multiply it out, 2 times x squared is 2x squared plus 2 times 3 is 6x, 2 times minus 1 is minus 2 plus 3. So minus 2 plus 3, that is plus 1. So it's going to be 2x squared plus 6x plus 1. This is g circles f. This is the function of g circles f. So to find the domain of this thing, I said earlier the domain of this one is all real numbers. This one is all real numbers. So therefore the domain of this one is going to be all real numbers. As you see, it's a polynomial. It's like the domain is all real numbers. Any number you put in here, it's going to give you an answer. So the domain is all real numbers. This is the domain all real numbers. X is such that X is a member of all real numbers. So any number you put in there is going to give you an answer. So the domain is all real numbers. Okay. The next question is to determine whether the function is a one-to-one function. So for a function to be one-to-one, this one I'll call this side like the input side and this one the output. It means you put this one in here to get the other side. So this inputs, every input side should correspond to exactly one output side. And on the output side, every output side should correspond exactly to one output side. For one input side, for it to be a one-to-one function. So we look at this one. This one corresponds exactly to this one and this one and this one. But both these 55 and 61 correspond to 38. And every single input should correspond exactly to one output, and one output should correspond to exactly one input. So it means this thing is not a one-to-one function because both these two are corresponding to this 38, and it should not be like that. These things they should be corresponding. It should be corresponding to their own output. So it means this one is not a one-to-one function. The A part is not a one-to-one function. So if we look at the B part, we can see like this is the input side, this is the output side. So this is minus 2 and 6, minus 1 and 3, 0 and 2, 1 and 5, 2 and 8. So this minus 2 corresponds to 6. It's like minus 2 is to 6, minus 1, 3, 0, 2, 1 to 5, 2 to 8. So it's like different from this one. This one, both the 55 and the 61 correspond to 38. So here there's no like number that both like there's no number where two of these stuff correspond directly to that number. And everyone like get its own. It's like minus 2 is different from minus 1, 0, 1, and 2. And the output 2 is different. It's like 6, 3, 2, 5, and 8 is different. Like everything is different on both sides. So therefore this thing is a one-to-one function because every input is corresponding to exactly one output. So this thing is a one-to-one function, but this one is not because both the 55 and the 61 are corresponding to 38. So this one is not a one-to-one function, but this one is a one-to-one function. Okay, we already did this one to determine whether the function is one-to-one. Now we're going to come for this one, but we're going to use like a different approach. This one we're going to use what they call the horizontal line test. So we're going to draw the graph of f of x is equals to x squared, and the graph of g of x is equals to x cubed. So we're going to use the horizontal line test to determine if a function here is one-to-one or not. So we're going to draw the graph of x squared. The graph of x squared is like this. This is y, this is the x. This is the graph of x squared. This point is 0. Let me see, this point is like here's 2 and here's 1. So the x is 1. Okay, now we're gonna use the horizontal line test. If it says like if you can draw a horizontal line and it crosses the graph on more than one point, the function is not one-to-one. If the line crosses the graph on more than one point, if it crosses the graph on only one point, then it's a one-to-one. But if it can cross the graph anywhere on more than 2 points, the function is not one-to-one. So for example, if we draw a line, a horizontal line here, it's like it's not straight, but I just assume it's a horizontal line. It passes the graph on more than one point. It passes the graph here, and it passes it here. So it means this thing is not a one-to-one function because it doesn't meet the criteria. It have to pass only once for it to be a one-to-one function. So this one is not. It's not a one-to-one function because it passed the graph more than once. It passed it here at this point. I can say like if this point is 2, so this point is like 2, and let me see here is 1 and -2. It's like it is 2 and okay, it should just be like if the line passes twice, it's not a one-to-one function. So this thing is not a one-to-one function. So we're gonna draw the graph of g of x is x cubed. G of x is x cubed. The graph is like this. This is the graph of x cubed. So if you look at this graph, any point that we draw a horizontal line, you can draw the horizontal line at any point. See, there's nowhere it can pass this graph more than once. It just passes it only once. You see here, it's only once. This one passes on this point and this point, so it's 2 times. So this one is not. This one passes only once. This one passes only once. So therefore, it is a one-to-one function. This one is a one-to-one. This one is not because this one does not pass the horizontal line test. This one passes the horizontal line test. It passes the graph at any point only once. This one passes twice, so it's not. Okay, this question we're going to find the domain of this thing, the range, and the domain and range of the inverse of each other pair. That's what we're going to do. So here to find the domain is like the input side, the range is the output side. So let's say like we put in -3 to get -27. So our -3 is going to be on our domain side, and -27 is going to be on our range side. So we start with the domain. So the domain is going to be on, let's assume that this one is x, this is the x side, and this is the y side of each other pair. Let's say like this is the x side, this is the y side. So always the one on the x is going to be our domain, and the one on the y side is going to be on our range. So this thing applies to all of them. So here our domain on the first one is going to be, let's say this side, domain is going to be -3. Our domain here, this one is on the x side, is going to be -2. Our domain here is going to be -1. The domain here is going to be 0. Here is going to be 1. Here is going to be 2. And the next one is going to be 3. So our range side is going to be on this side here, which is the first one. So when the first one is -27, -8, -1, 0, 1, 8, 27. So this one is the range, this one is the domain. So the next question is to find the range and the domain of the inverse. So we're going to find, we have to know how to find the inverse of this one. So when you're finding the inverse of other pairs, you just interchange them. That's going to be the inverse. Like what is here, you bring it here, and what is here, you bring it here. That's going to be our inverse. So we're going to find the inverse of this thing. So finding the inverse, we're going to interchange. So the first one, instead of -3 and -27, is going to be -27 and -3. That is the inverse of these other pairs. Like you switch them, you bring this one here and bring this one here. So the second one is going to be -8 and -2. The third one is going to be -1 and -1. If you switch them, it's going to be the same because it's -1, -1. So the fourth one too is it's going to be the same because it's 0 and 0. If you switch 0 and 0, you still have 0 and 0. The other one too is going to be the same, 1 and 1. If you switch it, it's still going to be the same. Next one is going to be now 8 and 2. If you switch it, it's going to come here, 2 come here. So the last one is going to be 27 and 3. it's going to be the last one. So this is the inverse of this function. We just find the inverse of this thing. Sorry, inverse of the ordered pairs. This is -3. The inverse of that ordered pairs here, the inverse of that, inverse of that. Now what the question said is to find the domain and the range of the inverse. So now, if we assume that this side is our x, this side is our y, so our domain is going to be the first one, and the range is always going to be the second one. So let's say like domain is on this side here. So I'm writing the domains. Domains is going to be now 27, -8, -1, 0, 1, 8, 27. The range, I'm writing the range here. So the range is going to be -3, -2, -1, 0. Next one is 1, 2, and 3. So this side is the ordered pairs. This is the inverse of the ordered pairs. This is the way domain and range here. This one is the domain. This one is the range. Okay, if you look at this thing, see this one and this one are exactly the same. And this is a domain, this is a range. So it means the domain of the ordered pair is equal to the range of their inverse. This is their inverse, this is the ordered pair. So the domain is the same as the range of their inverse. This one to the range of the ordered pair is the same as the domain of their inverse. You see, -27 is exactly the same, no difference. This one is exactly the same. So domain is equal to range of the inverse. Range is equal to domain of the inverse. The next question we're going to verify, we're going to come to verify inverse functions. How to verify two functions are inverse. So this is g of x is equals to square root of x. This one is g inverse. This is a sign to write inverse. Like g inverse of x is this is the sign you use to write inverse. So to verify g of x and these ones are like inverse functions, there is like a rule that applies. It's like it says g inverse of x should be equals to x. This is equals. Okay, g circles g inverse of x should be equals to x. If it is not equals to x, then it means this function is not the inverse of this one. So for this function to be the inverse of this one, this thing should be right. If this thing is not right, then it is not the inverse of this function. So that's what we're coming to verify. The question said this is the inverse of this thing. So we're going to verify how, like whether it is equals to x. If it is equals to x, then it's the inverse of this one. So we're going to do this thing, g inverse of x should be equals to x. So this is g inverse, this is g. Okay. So g inverse of x is going to be equals to, we put g inverse inside g. This is g. G is the square root of x. So we're going to put g inverse into this. So g inverse is equals to 3 root of x. We can write in the form of x raised to the power 3, x raised to the power 2, x raised to the power 2 over 3. This is the same as, sorry, this is x raised to the power 1 over 3. It's not 2 over 3. This is x raised to the power 1 over 3. So g of x, we can write g of x as x raised to the power 1 over 2. So if these two should be equals to x. So we're going to put g of x inside g. G is the square root of x, which is the same as x raised to the power 1 over 2. So it's going to be g of g inverse, which is equals to this, is what we're gonna put inside this thing. So this thing is gonna be equal to g into g inverse of x. It's gonna be equals to, we're gonna replace x with g of x. This is the same as 3 root of x. This is cube root of x. Cube root of x always to the power 1 over 2. This cube root of x always to the power 1 over 2. So this thing should give us x. If it doesn't give us x, then this thing is not the inverse of, these two functions are not the inverse of each other. So it's going to be g into g circles of x is going to be equals to x raised to the power, this should be 2 over 3 times 1 over 2. So it means this thing should be 3 over 2. So that this thing is. So this thing right here, it should be 3 over 2. Instead of 1 over 2, that's not right. It's supposed to be 3 over 2. It's supposed to be 3 over 2. So this thing is going to cancel, and this thing is going to cancel. So this thing is going to be equals to x. I don't think that's right. Probably that's a good one. Okay, I read out this thing wrong. It should not be square root of x. It should be x cubed instead of the square root of x. It should be x cubed. I write it out wrong. So I'm gonna go and get all this thing. Okay, I write out this question. It should not be the square root of x. It should be x cubed, and this is out. So it should be x cubed instead of the square root of x. I wrote it out wrong. So it's the same, like it's the same method. I just put like the wrong stuff in there, but it should be the same method. G circles G inverse of x should be equals to x. For this thing to be true, it should be the square root, the cube root, this x cube, it should be x cubed instead of the square root of x. So this thing should equals to x for this thing to be the inverse of this function. Now g inverse of x is equals to the cube root of x. G inverse of x is the cube root of x. So that's what we're going to put inside g of x. This is our g of x. So it means we're putting this thing inside this. So it's going to be equals to x. We're going to replace x with this thing. It's going to be 3 power x. Means we just remove this x and replace it with this thing. That's what we get right here. So this thing should give us x. If it gives us x, then we have verified it is right. So this thing is equals to, the cube root of x is the same as 1 over 3. X raised to the power 1 over 3. X raised to the power 1 over 3 is the same as the cube root of x. So this thing is equals to x 1 over 3 times 3. 3 is going to cancel. So it's going to be equals to x. I wrote out the other one wrong. I put the square root of x instead. The question is x cubed. So this thing is right. G g of x, this is the inverse of the function. So we get exactly x, so it means it's right. So the next one say f of x is equals to 2x plus 3 and f inverse of x is equals to 1 over 2 into x minus 3. So we're going to verify this thing. The answer should give us x, exactly like this one. So if you want, you can say like f inverse of f of x, like it can go either way. This thing should be equals to x. So let's just do this one and see if it is going to be equals to x. If it is equals to x, then I'll stop this one. So if we write out this one, f inverse of x is the same as, if we multiply this thing out, it's going to be 1 over 2x minus 3 over 2x. This times this, and this times this. 1 over 2x minus 3 over 2. So this is our f inverse of x. So we're going to put f of x inside f inverse of x. This is our f of x right here. So that is 2x plus 3. So it's like it's going to be f inverse of 2x plus 3 is going to be equals to, wherever we see x, this is what we're going to put in there, 2x plus 3. So this thing is 2x plus 3 minus 3 over 2. So if we multiply this thing out, it's going to be x plus 3 over 2 minus 3 over 2. Plus 3 over 2 minus 3 over 2 is the same as 0. It's going to be x plus 0, which is equals to x. So it means this circles, this is equals to x. Therefore, it is right. This is the inverse of this. So this is how you verify. So this one exactly is equals to x. We get x. So we verify those two. This one is how to find the inverse of the function. So we're going to find the inverse of this function. The other one we verified whether it is right. This one is the inverse of the other one. So this one we're going to find the inverse of this function. So to find the inverse of this function, the first step, I'll just assume that this f of x is the same as y. So I'll just say y is equals to 2x plus 1 all over x minus 1. Remember like what we did in the other pairs, like when we get 2 and 3, to find the inverse, we just switch. We said we assume this one was x and this one was y. So we just switch. It was like 3, 2 was going to be the inverse, like what we did earlier. So we're going to apply the same technique here. So what we're going to do is we're going to switch x with y to find the inverse. We're going to switch x with y and we solve for y. That's going to be our function. So here, if we switch x with y, it's going to be x is equals to 2y plus 1 over y minus 1. Like what we did is, anywhere I see x, I put y there, and anywhere y is, I just replace it with x. So now we're going to solve for y to find the function, the inverse function. We're going to solve for y. We already get x is equals to this. So it's the function, but let's just solve for y so that y is going to be equal. That's going to be like the inverse term. So when we making y the subject of the formula, it means y is going to come here where x is. So it's going to be, we multiply this thing out. If we do that, it's going to be x into y minus 1 is equals to 2y plus 1. So x times y is going to be xy minus x times 1 is x times negative 1 is negative x is equals to 7y plus 1. So this is going to be xy minus, I'm bringing this 7y here, so it's going to be minus 7y is equals to 1. This is minus x. If I bring it on this side, it's going to be plus x. I'm trying to put like the y's on the same side and the x on the same side. So I can get like 7y here. It's 2 plus 1. Okay, this is 2y. It's not 7y. I thought I was writing 7. This should be 2y. I don't have 7 in the question. This thing should be 2y, it's not 7y. I just wrote this thing, I thought it was a 7, but it's a 2. This is 2y plus 1, 2y plus 1, okay. So it's going to be xy minus, I think this thing here is going to be minus 2y. This 2y is what I brought here. And I took this x down here. It's negative x, so it's going to be positive x. It's positive 2y, it's going to be negative 2y. So I'm going to factorize this thing. It's going to be y into x minus 2. I'm bringing the y out of this thing. So it's going to be y into x minus 2 is equals to 1 plus x. So y is going to be equals to 1 plus x over x minus 2. What I did is divide here by x minus 2 and here by x minus 2 to get this y. So this is the inverse of f of x. Y is equals to 1 plus x over x minus 2. This is the inverse. So this is the same as f inverse of x is equals to 1 plus x over x minus 2. So now we can use the method we did in the earlier question to verify if this thing, what we did here, if this thing is right or not. Like this thing, we're going to say f circles of f inverse of x should be equals to x. So this thing should be equals to x if what we did here, if it is right. If it is not equals to x, then this thing is not right. So this thing should be equals to x. Now what we're going to do is we put f inverse of x into f of x, which is this one. So this is our f inverse of x is right here. So we're going to put it inside f of x. So if we do that, that's going to be f into 1 plus x over x minus 2. So this is what we're putting inside this equation here. So this is going to be equals to 2 into wherever we see x, we put this thing here. So it's going to be 2 into 1 plus x over x minus 2, x minus 2 plus 1 over x minus 2. So wherever we x minus 1, so it's going to be 1 plus x minus 2. We're replacing x with this thing here, minus 1. So if we work this thing out, we should get exactly x. If we get x, we know that this thing is right. Okay, I'm going to come down here. If we multiply this thing out, it's going to be 2 plus 2x over x minus 2 plus 1 over this thing right here. So this is 1 plus x minus 1 minus 1. If we want, we can do like this thing over 1 and we find like the common denominator, which is x minus 2. So it's going to be x minus 2 into this, which is 1. It's going to be 1 plus x. So x minus 2 into this is going to be minus x minus 1. 1 goes into this, x minus 1. So x minus 1 times 1. Yeah, that's exactly it. Okay, let's go. I'll put this one. Okay, this thing is good. Let's find the common denominator as x minus 1. X minus 2 is going to be the common denominator. X minus 2. So this thing is going to be, it's going to be 2 plus 2x plus x minus 1 all over what we get here. That is 1. This is minus x. This one is plus 1. So it's going to be 1 plus 1 is 2. X minus x is 0. So here everything we get is 2 over x minus 2. So here we can bring this in here and flip it and multiply it with this. If we do that, it's going to be 2 plus 2x. This is, okay, this thing is 2x plus x is 3x, and 2 minus 1 is 1. So this is 1 plus 3x over x minus 2. This is 2 minus 1 is 1. 2x plus x is 3x over x minus 2. So we're going to flip this thing and multiply it by this. It's going to be x. If we do that, it's going to be x minus 2 all over 2. So we're going to multiply this 2 and multiply this 2 and see if it will give us x. So if we multiply this 2, it's going to be 1 plus 3x into x minus 2 over, this thing is going to be 2x minus 4. It's going to be 1 times 1. It's going to be, let me just write down. 1 times, that is x minus 2 plus 3x squared plus 3x squared minus 3x all over 2x minus 4. Take 3x squared. Yeah, 3x squared. Now this is minus 6x. So it's going to be 6x. Okay, so this thing is 2 minus 2x, x minus 6x, that is minus 5x plus 3x squared over 2x minus 4. Is that nothing was concerned about? Okay, now we're gonna verify that if this thing, like what we just saw, is this thing is the inverse of, if this thing is the inverse of this function, that's what we're coming to verify. So for it to be the inverse, f inverse of x should be equals to x. So this thing here should be equals to x for this thing to be the inverse of this. Okay, so if we go on, it's going to be f into the inverse of f of x is 1 plus x over x minus 2. So that's what we're going to substitute inside f of x and see if it will be equals to x. So if we do that, it's going to be equals to 2 into, wherever we see x, we put this thing there. 1 plus x over x minus 2 plus 1 all over, this is x, so we substitute it with this thing here. Substitute this x with this thing here. It's going to be 1 plus x into x minus 2 minus 1. Now we're going to solve this thing and see if it is going to be equals to x. So by solving this, it's going to be 2 plus 2x plus 1 over x minus 2 all over, this is 1 plus x over x minus 2 minus 1. Okay, now we find the common denominator of this side here and this side here so that we can put the equations together. So that's going to be x, like we assume this line here means division. So I'm going to put division in between the two. So it's going to be, if I take the common denominator, it's going to be x minus 2 into, it's going to be 2 plus 2x minus x minus 2. I'll put it down. So this thing means division divided by the bottom part. So the bottom part, the common denominator is x minus 2. So it's going to be x minus 2, 1 plus x minus, I think this thing here should be plus instead of minus. This thing should be plus. This one is, let me erase this part. 1 plus x minus 2. So this thing is going to be 2 minus 2, which is going to be equals to 0, and 2x plus x, which is 3x. 3x over x minus 2 divided by, this is 1, this is minus 2 times minus 2, which is plus 2, plus 2 plus 3, that is 1, is, let me just write it out, it's going to be 1 plus x minus x plus 2 over x minus 2. So this is 3x over x minus 2 divided by x minus x is 0. 1 plus 2 is 3. 3 over x minus 2. Now we're going to flip this thing and change the sign to multiplication. So it's going to be 3x over x minus 2 times x minus 2 over 3. So this thing is going to cancel out. X minus 2 is going to cancel out. So it's going to be 3x over 3. 3 to cancel 3, which is equals to x. So it means this thing right here is equals to x. So therefore, this thing is y. F of x is the, f inverse is the inverse of this function here. This function is the inverse of this function. Because when you do this, you get your answer as x. Okay, this one is logarithm and exponents. So here we're going to change these logarithm statements. We give it logarithm statements. So we're going to change them to other statements that involve exponents. So that's what we're going to do in this question. So that's the rule like we should follow. So that's just like this. If you get log A base B is equals to C, it's the same as B raised to the power C is equals to A, but A cannot be negative, a negative number, because logarithm of negative numbers does not exist. So you cannot get a negative number here. So this thing, log A base B is equals to C, is the same as B raised to the power C is equals to A, and the logarithm is not going to be there anymore. This is going to be the exponent form. So we're going to use this rule to solve these three fractions. So here we're going to do exactly the same thing we did here. It's just, you're going to go A raised to the power 5 is equals to 4. A to the 5 is equals to 4. It's same as here. B to the C is equals to A. A to the 5 is equals to 4. So we're going to do exactly the same thing here. This one is going to be e to the negative 3 is equals to b. This one is going to be exactly the same thing too. 3 to the c is equals to 5. So that's how to do this thing. A to the 5 is equals to 4. Just follow this rule. B to the C is equals to A. A can be any number except negative numbers. C can be any number. B can be any number. So you just go b to the c is equals to 8. This one we're going to find the exact numbers of these logarithm expressions. These are logarithm expressions. So we're going to find the exact answers to this one, like the exact number to this thing. So here, the first thing we're going to do, this is log 16 base 2. This is base 2 and this is log of 16. So we're going to see if we can make this 16 into, we can change this 16 into something where we can have 2 as the base and we get another exponent. So if you see like 2 raised to the power 4 is equals to 16, because 2 times 2 is 4, 4 times 4 is 8, 4 times 2 is 8, 8 times 2 is 16. So log 2 to the 4 base 2. This 2 to the 4 is the same as 16. 16 is equals to 2 raised to the power 4. It means 2 times 2 times 2 times 2 is equals to 16. So we can write this on this form. So when a logarithm when the log of the number and the base are the same, it's equals to 1. And there's a rule that says we can bring this 4 back here. So if we bring this 4 back here, it's going to be 4 log 2 base 2. And log 2 base 2 is equals to 1. So this is going to be 4 times 1, which is equals to 4. So the exact answer to this logarithm expression is 4. You just try and change this 16 to base 2 so that you can put the other number back there and you take this thing as 1 and your answer is going to be equals to 4. So the next one is log 1 over 27. So here the base of the logarithm is 3. Here the base was 2. We change this number in a form that we get 2 as the base of an exponent. So this one we're going to do the same thing to see if we can get 3 out of this term. So it's going to be log 1 over 27. It's the same as 1 over 3 raised to the power 3. 3 raised to the power 3 is equals to 27. It means 3 times 3 times 3 is 27. 3 times 3 times 3 is 27. So 3 to the 3 is equals to 27. So we're going to replace this 27 with 3 to the 3. So it's going to be 3 to the 3. So it's going to be logarithm of, if we want to put this thing up, it's going to be 3 to the, it's going to be 3 to the negative 3. Like we put it this thing up. This thing is like the inverse of, if we take it up, we're going to put a negative here. This thing is the same as this 3 raised to the power negative 3, same as 1 over 3 raised to the power 3. So we get base 3. So we can bring this negative 3 down here. It's going to be negative 3 log 3 base 3. Log 3 base 3 is 1. If this number and this number are the same, it's 1. It's like you say log a base a is equals to 1. If these two numbers are the same, answer here is 1. So this thing is going to be 1. So it's going to be negative 3 times 1, which is negative 3. This is the answer to this logarithm expression. Okay, this one here, we get a logarithm equation. So we're going to solve this logarithm equation. So to solve this logarithm equation, there's like one rule which say log of a plus log of b is equals to log a times b. Log of a plus base c, if the bases are the same, it's going to be log a times b. So we get exactly the same thing here. So this rule is what we're going to apply here. We get this one is base 5, this one is base 5. So we assume this one is our a, this one is our a. So the answer is going to be log A times B. I mean, this thing is like A, and this thing is our B. This is a rule. It applies to any type of question. It can be a different stuff. This thing can be different, and the other stuff can be different too. So this thing is log. It's going to be log x plus 6 times. Now it's going to be times x plus 2 is equals to 1. Let me see if that is 6. Yeah, that is 6. So this thing is going to be equal to 1. The base is 5. This is 5. This is 5. So the base is going to be the same, 5. So what we did on the earlier question is, it was this where you say log A base B is equals to C, the same as B raised to the power C is equals to A. We're going to get the same thing here. It's going to be 5 raised to the power 1 is equals to what we get here. So this is going to be x plus 6 into x plus 2 is equals to 5 raised to the power 1, which is the same as 5. So if we multiply this thing out, we're going to get x squared plus 6x plus 2x. 6 times x, yeah, is 6x. X times 2, 2x plus 2x. 6 times 2 plus 12 is equals to 5. So we bring this 5 here so we can get our quadratic equation. This is going to be x squared plus 8x plus 12 minus 5 is equals to 0. 12 minus 5 is 7. So it's going to be x squared plus 8x plus 7 is equals to 0. So we're going to, this is a quadratic equation. We're going to solve this thing to figure out what the values of x are. So we use the factorization method. We look at two numbers that when you multiply them, they're going to give you 7. And when you add them, they're going to give you 8. Okay. 7 times 1 is 7. 7 plus 1 is 8. So when you multiply the two numbers, they're going to give you 7, which is 1 times 7. And when you add the same two numbers, they're going to give you 8, which is 1 plus 7 is equals to 8. So we replace this 8 by 1 and 7. So it's going to be x squared plus 7x plus x, which is the same as that 1, plus 7 is equals to 0. So this thing is going to be x into, this is 7, it's going to be 7x. Now it's going to be x into x plus 7 plus 1 into x plus 7. So this is going to be x plus 1, x plus 7 is equals to 0. So x is going to be equals to, x plus 1 is equals to 0, and x plus 7 is equals to 0, which is x is equals to -1 and x is equals to -7. So let's see if all these answers are going to work here. If we put -1 here, x for -1, -1 plus 6, that is +5, -1 plus 2, that is +1. So it means x is a possible answer because we can get the logarithm of all possible numbers, positive numbers can work. So it means x is equals to -1. That is right. So our second answer is x is equals to -7. So if I put -7 here, -7 plus 6 is -1. And logarithm of negative numbers does not exist. You cannot get a logarithm, the logarithm of a negative number. So x is not equals to -7. So we discard this one. We're going to get only this one as our answer. X is equals to -1. That is the answer to this equation.